This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy. We go deep and lightly surface the big ideas. Okay, let's unpack this. You shared some really interesting sources with us, kind of pushing us to think beyond just the initial COVID-19 illness.
Yeah.
Because it turns out this virus might have some unexpected, lasting effects, especially on the brain and, well, our behavior.
That's really been one of the biggest shifts, hasn't it, in how we understand SARS-CoV-2.
Mm-hmm.
Just the realization that it's not solely a respiratory thing, but something that can impact the central nervous system and our well-being in pretty persistent ways.
Absolutely. And that's exactly what we're going to dive into today. We're exploring these lasting sort of post-infection effects of COVID-19.
Right.
Looking at potential changes in the brain and how they might influence, cognition and behavior, both in adults and in kids.
And this deep dive is specifically for you, our listener. We're pulling together the most important nuggets from the research you pointed us to.
Yeah, trying to give you a clear picture of what the science is suggesting right now. We're drawing from a couple of key studies here. There's a big brain imaging study from the UK, published in Nature. It has some really unique strengths.
Right, the biobank one.
Exactly. And also a study looking at behavioral and social changes in children over in Taiwan. That one's from the Journal of the Formosan Medical Association.
Okay, so maybe let's start with the adult brain, because that UK biobank study in Nature, it offers a pretty striking perspective.
It really does. And what makes it so valuable, I think, is that it's longitudinal.
Yeah, that's key.
They had MRI scans of people before the pandemic even hit. Then they scanned them again after some of them had gotten COVID.
Which lets you compare the changes over time, in the infected group versus a control group who didn't get infected.
Exactly. That pre-infection data is just gold, isn't it?
It really is.
It helps confirm the changes they saw were actually associated with the infection, not just some pre-existing difference.
Right. So they looked at 785 participants aged between 51 and 81. They all had these two scans.
Right.
401 of them tested positive for SARS-CoV-2 between those scans, and 384 were the controls. And crucially, most of the infected cases were mild to moderate.
Ah, okay. Not just severe cases, then.
No, only 15 needed hospitalization. So the potential effects they found weren't just limited to people who got really, really sick.
Right. So when they compared those scans, the before and after, what kind of physical changes did they actually notice in the brain?
Well, one of the most surprising findings was evidence suggesting actual physical alterations. The group that had COVID showed a greater reduction in gray matter thickness in specific areas compared to the control group.
Gray matter. That's like the brain's processing tissue, right? The neurons themselves.
Sort of, yeah. It's involved in muscle control, sensory perception like seeing and hearing, memory, emotions, speech, decision-making, self-control, all the higher functions.
Okay. And where did they see these reductions most clearly?
The most prominent effects were in regions linked pretty heavily to smell and memory processing.
Ah, smell and memory. That makes sense, given the symptoms people report.
Exactly. Specifically, the orbitofrontal cortex and the parahippocampal gyrus.
Yeah.
But they also saw differences in other areas, especially in the temporal lobe, areas functionally connected to these primary ones.
And you said this was even in people who had milder cases, not just the ones who ended up in the hospital.
Yes, that's a key point. The effects were still there, even when they took out the small number of hospitalized cases from the analysis.
Wow.
Now, the hospitalized individuals, they did show a more widespread pattern of this gray matter reduction. It extended into regions involved more in attention and processing information, too.
Interesting. Okay. Did they notice anything else, like about the overall size of the brain?
They did, yeah.
Yeah.
The study found a greater reduction in overall global brain size in the people who'd had SARS-CoV-2.
A reduction in size.
And that was accompanied by an increase in the fluid surrounding the brain, the cerebrospinal fluid, or CSF.
Wow. Okay, so not just specific areas thinning, but an overall volume reduction, too. How significant were these changes? Like, are we talking massive differences?
No, not massive. The scale was described as modest, ranging from about 0.2% up to maybe 2% of the baseline values in those affected regions.
Okay, 0.2 to 2%. How does that compare to, say, normal aging?
Well, the researchers put it into perspective. They noted that this level of change in certain areas like the hippocampus was comparable to roughly 1 to 2 extra years of typical age-related decline.
1 or 2 extra years.
Compared to the control group, yes. So not huge catastrophic changes, but statistically significant differences that seemed linked to the infection.
Adding a year or two of apparent brain aging, I mean, that feels pretty striking, even if it's modest percentage-wise.
Does make you think.
Do the researchers have ideas about why this might be happening? What's the mechanism?
They proposed a few potential mechanisms. One theory, which fits the pattern of affected areas quite well, is a kind of degenerative spread of the virus's effects, starting from the olfactory pathways.
Ah, the smell pathways again.
Right. Think about how common losing smell and taste was, especially early on. Another possibility is neuroinflammation, the infection triggering inflammation in the brain, or potentially changes happening simply because of the loss of sensory input itself, like if you have prolonged loss of smell.
Okay.
They also looked at something called diffusion indices. These are markers that can tell us about the sort of microstructural integrity or maybe damage within the brain tissue. And they found changes there too, again, in areas connected to the olfactory cortex.
Okay, so we've got evidence of physical changes, gray matter thinning, some overall volume reduction, changes in tissue markers happening in adults, even after fairly mild infection. For you listening, what could these physical changes actually mean?
Well, these are the brain's fundamental building blocks and connections we're talking about. So changes here, particularly in areas tied to smell, memory, and executive function.
Oh.
Yeah, they certainly have downstream effects on how the brain operates day to day.
Which, leads us perfectly to the next piece. Did these potential physical changes actually correlate with changes in how the brain works, specifically things like cognition?
Yeah, exactly. The Nature study also looked at cognitive function in these participants, and they found a greater cognitive decline in the infected group between their two scans compared to the controls.
A cognitive decline. How do they measure that? What kind of tests?
The most significant differences popped up in tasks that assess executive function and attention, particularly the trail-making tests.
Ah, the trail-making tests. I think I know those. That's the one where you connect numbers or switch between numbers and letters, right?
That's the one.
Testing things like mental flexibility, processing speed.
Exactly that. Trail-making test part B, which involves switching between numbers and letters, is especially sensitive to executive function and attention.
And what did they find?
The infected group took significantly longer to complete these tests after their infection, compared to how they did before, and also compared to how the control group's performance changed over that same time.
Longer time means slower processing or more difficulty switching tasks.
Likely a combination, reflecting a hit to that executive function and attention capacity.
And just to be clear, this cognitive decline, was that also seen even when they excluded the hospitalized patients?
Yes, it was. It was present even in the milder cases, which mirrors the pattern they saw with the structural brain changes.
Interesting consistency there.
And the researchers also noted a sort of post hoc finding linking the specific cognitive decline the longer time on Trail B with changes in a particular part of the cerebellum.
The cerebellum. Isn't that mostly for movement?
Traditionally, yes, but we now know it's heavily involved in cognition and, interestingly, also linked to olfactory processing. So it fits the pattern.
Okay. It's worth noting, too, I think, that the study did look at other cognitive tests, right? But the really clear, significant decline over time was most obvious in these executive function and attention tasks.
That's right. And they also made a point of emphasizing something important about the baseline.
Which was?
Well, even though the group who later got COVID happened to show some subtle cognitive differences even before the pandemic started, those small baseline differences did not explain the significant decline they saw after the infection. The decline went above and beyond their starting point.
Ah, okay. So that pre-infection data really is crucial again.
Absolutely. It helps rule out the idea that maybe these people just had lower cognitive function to begin with. The change happened over time, and it was associated with getting COVID.
Right. So thinking about this for you, the listener, if you've had COVID and maybe felt like your brain isn't quite the same, how might this kind of decline in executive function and attention actually show up in daily life?
Well, it could manifest in different ways, maybe finding it harder to really focus on a task or feeling less mentally sharp than usual.
Brain fog?
Could be part of it, yeah. Or taking longer to process information, maybe having more difficulty planning things, organizing tasks that used to feel easier, that sort of thing.
Okay, so we've explored these potential structural changes and cognitive shifts in adults from that big UK study. Let's pivot now and look at the other source you shared, which brings in a whole different group.
Right. This study comes from Taiwan, and it focuses specifically on the effects of COVID-19 infection on behavioral, emotional, and social problems in kids.
Gives us a really crucial view beyond just the physical brain impacts.
Exactly. How does it affect their day-to-day functioning, their interactions?
So how was this study set up? Did they also have baseline data?
Yes. Similar approach in some ways. They compared children before COVID, then after they're infected, and also against a control group of kids who hadn't been infected.
Okay. And how did they measure these behavioral and social aspects?
They used well-validated questionnaires that parents filled out. Things like the Child Behavior Checklist, the CBCL, and the Social Adjustment Inventory for Children and Adolescents, or SECA.
Right, so established tools.
They capture a really wide range of potential issues: emotional regulation, social interactions, behavior at school, attention problems, things like that.
And what were the main findings? How did COVID seem to affect children's behavior and social adjustment in this study?
The headline finding was that the children who had been infected showed increased problems across these areas: behavioral, emotional, social adjustment after their infection compared to how they were before COVID.
Okay, an increase in problems.
Yes, and also compared to the control group.
Were there specific areas where this was most noticeable?
The sources highlighted impacts on overall school functioning, like their attitude towards school seemed to worsen. Also effects on their social interaction skills, more behavioral problems reported at school, and interestingly, they seem to have less active interactions with their parents after infection.
Less active interaction with parents, that's quite specific.
It is. It suggests maybe some withdrawal or change in family dynamics, perhaps.
Did the study notice any differences between boys and girls?
Yes, this was another really significant finding they reported. There's a pronounced sex difference. Girls who had been infected showed more widespread and severe behavioral, emotional, and social adjustment problems compared to boys who'd been infected, especially when compared against controls of the same sex.
So girls seem to be more significantly impacted in these particular domains.
That's what this study suggests, yes.
What kinds of problems were more severe for the girls?
Well, the data pointed to girls experiencing more severe issues with things like inattention and also oppositional behaviors.
Okay.
They also scored higher on various subscales of that CBCL checklist, indicating more problems with aggression, anxiety, depression, social difficulties, withdrawn behaviors.
Wow, quite a range.
Yeah, and also poor adjustment reported in school, with their peers, and at home compared to the control girls.
And what about the boys?
Boys also showed some increases in problems compared to controls, but the pattern just wasn't as widespread, and the severity seemed less pronounced than what was reported for girls in this particular study.
Interesting. Did they have any ideas why?
The study noted the mechanisms aren't clear. Could be direct viral impact, neuroinflammation, similar ideas as in adults, but maybe manifesting differently in kids or with different sex-based vulnerabilities.
Yeah.
They also mentioned something important about pre-existing conditions.
Right.
Yeah, they noted that children who already had mental health conditions, like ADHD, for example, might actually have been more susceptible to getting infected in the first place.
Ah, okay. So that could complicate the baseline comparisons a bit.
It could, yeah.
Yeah.
It might explain why even the pre-COVID group showed slightly more problems than the controls initially. But the key finding remained: the significant increase in problems after infection compared to their own baseline and compared to the control group.
That distinction is important. Okay. So, for you listening, thinking about the kids you know, how might these kinds of behavioral and social findings show up in their lives or for their families?
Well, it could translate into things like struggles keeping up or behaving appropriately in school, difficulty navigating friendships, maybe more friction in social situations. You might see noticeable changes in their behavior at home, maybe more withdrawn or perhaps more irritable. Challenges managing emotions could be part of it too.
Right. These are the kinds of real-world impacts families might potentially be observing.
Exactly.
Okay, so we've covered quite a bit here. We've got potential structural brain changes and cognitive impacts in adults, and then the significant behavioral and social challenges cropping up in children post-infection. How do we kind of connect these dots? What's the bigger picture emerging?
Well, I think when you put it all together, these different studies, even though they used different methods, looked at different populations, they collectively point towards a pretty wide range of lasting post-COVID effects. Effects that impact the nervous system and its functions.
Yeah, it's not just one single thing.
No, it seems to be affecting different aspects. Brain structure, cognition, Behavior across different age groups is complex.
And it really does underscore the value of those studies that have longitudinal data, right? Like the UK Biobank one with the scans from before the pandemic.
Absolutely. Seeing changes happen after an infection, especially when you compare it to a control group and the person's own baseline, that provides much stronger evidence linking these outcomes to the virus itself, rather than just other factors.
It's also really crucial, though, to remember the limitations, right? The researchers themselves point these out.
Oh, definitely. Yes.
Yeah.
They're always very clear about that. Things like needing much longer follow-up periods.
To see if things get better or worse or stay the same.
Exactly. Are these changes permanent? Is recovery possible over time? But we don't know that yet from these snapshots.
What else?
They also mentioned needing more data on specific viral variants. Did Omicron affect the brain differently than Delta, for example?
Good point.
More detailed clinical info about the infection itself, severity beyond just hospitalized versus not hospitalized.
Right.
Like, did specific symptoms like loss of smell correlate more strongly with certain brain changes?
Right.
And of course, larger and more diverse samples are always needed. Plus, better ways to account for all the other potential confounding factors in people's lives. Research is definitely ongoing.
Understanding those limitations is key to interpreting this properly, but stepping back, why is staying informed about this kind of research important for you, the listener? Why should you care?
Well, I think because it really expands our understanding of this virus way beyond just the acute phase, the initial sickness. Recognizing these potential lasting effects, well, it can inform decisions in healthcare, right? How we approach long COVID. It can affect how we support children in schools, knowing they might be facing these extra challenges. Public health strategies might need to adapt. And ultimately, it helps us grasp the full complexity and plan for long-term recovery and well-being for people in communities impacted by COVID-19.
It definitely highlights that the story of COVID-19, particularly its long-term effects, is still very much unfolding.
Absolutely.
So, based on everything we've discussed, these findings showing subtle yet significant structural changes, the cognitive decline, the behavioral issues, especially in those brain areas linked to memory and smell. What does this imply for the really long haul?
Yeah, that's the fundamental and maybe the most profound question these studies raise, particularly that Nature paper on the adult brain changes. Given the changes they observed, modest as they were, in regions crucial for memory, and regions hit early via the olfactory system, could these findings suggest, potentially, an increased risk for neurodegenerative conditions, things like dementia, maybe Alzheimer's, years or even decades down the line?
That's a heavy question.
It is.
Yeah.
Or will the brain's amazing plasticity allow for recovery over longer periods? Periods longer than these studies could capture. We just don't have the answers yet.
That question definitely gives you pause, doesn't it? We've taken a deep dive today into some really fascinating and maybe slightly concerning research, exploring the potential lasting impact of COVID-19 on the brain and behavior.
Yeah, from those physical changes and cognitive shifts seen in adults
to the behavioral and social challenges observed in children.
And that provocative question about the very, very long-term implications for neurological health. Really lingers. It's a space that absolutely needs continued research, continued attention from scientists, from doctors, from public health. From all of us, really. Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other podcasts, responding to the content, and checking out our related articles at helioxpodcast.substack.com.